So this is a video on the homework. Again, these are meant to kind of be a resource if you're stuck on a problem. I do want you to try them before you watch the video and then come back to the video to see the ones that you're having trouble with and fast forward to those. So here are the formulas for the double angle for cosines. Okay, so cosine 2 theta, we have 3 of them. Okay. Let me also jot up here if we have sine of 2 theta, that's going to be 2 sine theta times cosine theta. I'm going to move it over a little bit. Okay, so 2 sine theta cosine theta. Okay, so that's going to be if I have a double angle for a sine, and the other one's if I have a double angle for a cosine. Okay. So this is for all, so we got to do that plus or minus. And on this case, this actually is a triple angle, okay, which we don't have a formula for this, but there's only my cosine of that angle and numbers. So I'm just going to isolate my cosine. Okay, so I'm going to get my 2 cosine 3x by itself. So I am going to add 1, divide by 2, and then I want to know, hey, where's a cosine? Now it's cosine 3x, where it's really 3 times the angle, but that doesn't matter. We'll figure out what that angle is here in a second. I want to know, where is my cosine equal to a 1/2? So cosine is your x coordinate on your unit circle. So if I'm looking at my unit circle, I want short comma long. That's what I want. So I'm going to be looking right here at pi thirds. And my cosine is also positive down here at 5 pi thirds. And then remember, it is for all. So we want to add plus or minus 2 pi n unless I can get there in a shorter distance between these. Okay. So here to here versus going the other direction from pi thirds to there, you see that those are not equal. So I don't have an amount I can add to pi thirds and subtract to pi thirds to get back and forth between those two values. So I am going to not take x, but 3x instead equal to pi thirds plus or minus 2 pi n. I'm going to do the same with the bottom. Let me just work this out. I am going to divide by 3 to get this to be an x. Now, when I divide my pi thirds, that becomes pi ninths. The 3 gets in the denominator. So I am going to have x is equal to pi ninths plus or minus 2 pi thirds n. Okay. And then I'm going to do the same here. I'll do it in, let's say, black for this one here. So I'm going to have, 3x is equal to 5 pi thirds plus or minus 2 pi n. And again, I am going to divide by 3. So when I divide that by 3, I get 5 pi ninths, and I divide that by 3. And so another answer is 5 pi ninths plus or minus 2 pi thirds n. And that's going to be another answer. Now, on number 2, we're going to have to use some of those formulas. So the formula I'm going to use is when I have a hot pink up here, okay, because this is 2 sine x. And then this one's just plain sine x, okay? And I shouldn't say 2 sine x, sorry, sine of 2x. And the other one's sine of x, okay? So that when those are different angles, we can't factor those. They have to be the same angle. So I'm going to be using the fact that sine 2x is going to be 2 sine x cosine x. And then the rest of that equation is still plus sine x equals 0. And when it's equal to 0 and you can factor, we want to factor. So I noticed that both of them have a sine x, so I can pull a sine x out. And so I'm going to get sine x times the quantity 2 cosine x plus 1 equals 0. So now I want to set these to 0. So this one here is going to be what makes sine x equal 0. And then the second one is going to be what makes my cosine x. And if I try to get my cosine x by itself, I'm going to minus 1 and divide by 2. So I get a negative 1/2. So let me first start with my sine. And again, all of these are like the for all. So we're going to have to be adding, subtracting, maybe 2 pi n. Okay, so sine is your y. I want to know where's my sine or y 0. So that's going to be at 0. And it's going to be at pi. And then I want to pay attention to the distance between these, because if I can go shorter than 2 pi, then to get from one to the other. Okay, and when I say that, I mean, honestly, we're going from 0 to 0, but if I can get to the other one equal distance, I don't have to write separate ones. So both of these are pi away from each other. So I can write my answer. I'll write it over here in blue. X is equal to 0 plus or minus pi n. Or you don't even have to put the 0. You can just leave it as plus or minus pi n. And then I want to look at my cosine. And so my cosine here, where is it equal to a negative 1/2? Well, cosine's negative in quadrant 2 and 3. So that's where I'm going to be looking. Cosine is your x, and I want my x to be a negative 1/2, which means I want it short. Short, long. Okay, that's what I'm doing. So I'm going to be here, which is at 2 pi thirds. And I'm also going to be down here, which is 4 pi thirds. And those are going to be my two angles that give me that. And then again, if I look to see how can I move from one to the other. So if I'm going from this purple one to this purple one, okay, versus if I go the other direction, you see it's not the same distance between. So I'm going to have to give two separate answers. I can't write it as one. So I'm going to have x is equal to 2 pi thirds plus or minus 2 pi n. Okay. And I'm also going to have x is equal to 4 pi thirds plus or minus 2 pi n. And those are your answers. Okay, on number 3. So on 3, I notice I have a sine 2x and a cosine 2x. So the sine 2x is going to be the easy part of that because there's only one way to write that. So that's going to be 2 sine x cosine x. Okay. Now, the one that's going to be more of the problem here, let me just write it here in black to begin with, is going to be this one. So for that, I have these 3 different ones. And you might just have to do trial and error. So I'm looking at these. At first glance, I'm thinking, hey, this is a sine x cosine x. Maybe that's a middle term. And I want a cosine squared and a sine squared. I'm just concerned with this 1. I think that 1's going to get in the way. So I'm thinking I want to get rid of that 1. Now, the thing to remember is this one here is a minus. So whatever I put here is going to become opposite. So if I want to have it cancel out here, this one is not going to, because when I minus this, I'm going to get a -1, which means I'm going to add 1 to the other side, and I'm going to get a 2. This one here, when I make this one opposite because of the negative, this is going to become a +1. And then I can subtract 1 from both sides. So I'm thinking this one. But again, you can try this and see what happens. If it isn't going right, then try any of these until you get the answer. Okay. But that's just kind of my reasoning as I'm thinking maybe I don't want this 1 here because I already have a lot of stuff going on with sines and cosines, and I probably want to factor, and that 1 there is probably not going to help me out. So I am going to have my 2 sine x cosine x, which was again my sine 2x, minus, and then for this one here, I am going to put in parentheses, and I'm going to do the one that had the minus 1, which was my 2 cosine squared x minus 1. And again, I'm going to see if this works. If it doesn't, I'll try one of the others. Okay. So when I clean this up, I've got 2 sine x cosine x minus 2 cosine squared x. So right now I could factor a cosine from both terms. The only thing is that 1 tagging along on the other side is kind of my issue. But when I have this negative that's going to distribute to this, I'm going to get a +1. And now what's going to happen is I can actually -1 from both sides, and those are going to cancel out. So I am going to get 2 sine x cosine x minus 2 cosine squared x equals 0, because I'm really minusing 1 from both sides. I also noticed that I could divide by 2, divide by 2, divide by 2, and then I get sine x cosine x minus cosine squared x equals 0. I think that's a little easier. Now that I have a 0 on the other side, what I notice is I've got a cosine x and a cosine squared x. So I can factor out a cosine x. And I'm going to be left with a sine x from the first term minus a cosine x from the second term. So let's see. Let's see if that's working out. That doesn't work out, then I'm just going to go the other way. So I actually think this will work. It's not ideal with the sine x cosine x, but I think it'll work out for us. So I'm just going to kind of zoom up a little bit. Okay. And here I'll write what problem this is. This is problem 3, so we can see what problem we're on. Okay. So in order to get these equal to 0, for this one, that means my cosine x has to be 0. For the one in black, that means my sine x has to equal my cosine x. They have to equal each other so that when I subtract them, they cancel out. And so that's doable. So where is my cosine equal to 0? And cosine is your x. So that is going to be up here at pi halves and down here at 3 pi halves. And these are directly across from each other, but you can also see how, whoops, trying to get a different color, how it's going the same distance here as it is here. So that means that that answer, oops, trying to write it in blue, that answer is going to be pi halves plus or minus 2 pi, sorry, plus or minus pi n, because they're pi away from each other. Now for the second one, we want to know, hey, where does your sine and your cosine equal each other? That is going to be at my pi fourths. So it's going to be here at pi fourths because both of them are root 2 halves comma root 2 halves. Now over here, that's not going to work because they're going to be opposite signs. This one's going to be a negative and a negative, so that will work. So that's going to be 5 pi fourths. And again, this one, they're going to be different signs, so that's not going to work. And you'll notice that these are directly across pi away. Again, visually, trying trying to grab a different color. The distance from here to here is pi, and the distance from here to here is also pi. So I don't have to add 2 pi n to both of them. I can write this as pi force plus or minus pi n. And that will give me my pi n. Said it, didn't write it, pi n. And so those are your answers. Okay, so let's take a look at number 4. Okay, so this one, first off, we want to pay attention that this is a cosine of 2a, where this is a sine of just a, okay? And it's in quadrant 2. So if it's in quadrant 2, I know that if this is my a, sine is opposite over hypotenuse. And this is Pythagorean. Hopefully you recognize this as a special triple 5, 12, 13. And actually that's going to be a negative 12 because of the quadrant it's in. But if you don't recognize that, then you're going to do Pythagorean. I'll just kind of jot it real quick. You would do 5 squared plus x squared equals 13 squared. So you would get 169 minus 25, which is 144. And the square root of 144 is 12. And the reason it's negative is because my x is negative in that quadrant. Okay, so now I want cosine 2 of a. So I'm going to use one of these formulas. Okay. So doesn't matter which one. I think I'm going to actually use the second one because I actually know my sine of my a. And so I can just square that and put that right here. So I'm going to use this. So I'm going to use 1 minus 2 sine squared a. So again, cosine 2a is equal to 1 minus 2 sine squared a. And so this is going to be equal to 1 minus 2, and sine of a is 5 over 13. So this is 5 over 13 squared. So that's going to be 1 minus 2 times 25 over 169. So that's going to be 50 over 169. And then all I need to do for that, and so actually I didn't even, depending on which formula, if I wanted to use the one with the cosine, then I would have needed this. I used the one with the sine, so I didn't actually need that, but I could have used that formula if I preferred. So one is really can be rewritten as 169 over 169 minus 50 over 169. So that is going to give me 119 over 169, and that is my answer. And on number 5, so this is where we want to use the sum and difference formulas. I want the one where you have sine and cosine with a minus. So that is going to be this one right here. Okay, we got the sine and cosine together in a term, and then there's a minus. So it's the sine of a difference. Okay. So I'm going to rewrite this as sine of pi 12ths minus 7 pi 12ths. And so that's going to be sine of negative 6 pi 12ths, which is going to be sine of negative pi halves. And I didn't draw a unit circle here, sorry. So on the unit circle here, negative pi halves would be going this direction. So I'm going to be down here, which is really kind of like normally 3 pi halves. And this point is 0, negative 1. So the sign is going to be negative 1. And that would be my answer. Again, I was able to find that even though I don't know 12ths on my unit circle, because that ended up becoming, when I subtracted them, a nice radian. Okay, on number 6, so on this one, let's see. So I am going to try to get my sine squared of 5x by itself first. So I'm going to have 4 sine squared 5x. I'm going to add 1. I am then going to divide by 4. So that's going to be a 1/4. I then am going to square root, but my 5x is still constantly there. My angle hasn't changed yet. So when I square root, I get a positive and a negative. The square root of 1 is 1, and the square root of 4 is 2. So I basically want to figure out where my sign is a negative 1/2. So sine is your y. So I want my y to be negative, which means I'm down in these quadrants, 3 and 4. And actually, I want it to be a positive and a negative. So I'm going to be in all 4 of these. But I want my y, which is my sign, to be short. So that means I'm going to go long, comma, short, which is going to put me here at a pi 6 and also a 5 pi 6 and also a 7 pi 6 and an 11 pi 6. Now, if I'm trying to see how I can write it between these, from here to here, that would be a 4 pi 6 distance. But from here to here, I'll do it in orange. This would only be a 2 pi 6. So that's not going to be the same going back and forth between all 4 of these. But what I can do is that going from my pi 6 to my 7 pi 6, that's 6 pi 6, which is pi. So I'm going to have 5x is equal to pi 6 plus or minus pi n, and then I'm going to divide by 5. And so when I divide by 5, I'm going to get x is equal to pi 30ths plus or minus pi 5ths n. Okay, and then if I am going from here, 5 pi 6 to 11 pi 6, again, that's 6 pi 6 or pi. So I'm going to do a similar idea. So I'm going to have 5x is equal to 5 pi 6 plus or minus pi n. I am going to divide by 5. So I'm going to get x is equal to, when I divide by 5, I get 5 pi 30ths or pi 6 plus or minus pi 5ths n. And that's going to be my answer.